Alright, let's look at one AMC 12 problem. It is not directly related to the Newton's identity, but is related. So the question is, we are given x, y, z real numbers such that they satisfy these two equations. And then we have some real number a and b such that, x cubed plus y cubed equal in terms of this number a and b. So we try to find out what is the sum of a plus b. Notice that when you look at the problem, the entity here, x plus y, x squared plus y squared, s cubed plus y cubed. So this is why you may find that it could be related to Newton's identity, even though we're not going to use identity directly, but the algebra tricks is the same, right? So this problem comes down to how x cubed, the sum of x cubed plus y cubed, is related to x plus y and x squared plus y squared. If recall in the analysis of Newton's identity, you know that for x squared plus y squared, right, is equal to x plus y squared minus 2xy, right? That's we know. Because we always try to relate a higher power sum to a lower power, right? This is in our notation, this would be S3, this would be S1, and this would be S2. Now, similarly, S3 is related to S2 and S1. So x cubed plus y cubed would equal x squared plus y squared times x plus y, right? This is the trick we use all the time. There's some extra term, the cross term, you have to subtract to make it equal, right? So you have to subtract x times y squared, y times x squared. Now, if you further simplify the second part by factoring out xy, right? And then you have x plus y. All right. So now we find that there's a term xy that we don't know, right? Everything else can be expressed. This is given because from first of all, from this logarithm, you know that x plus y, right, equal 10 raised to the z power, right? Here, you know that x squared plus y squared equal 10 raised to z plus 1 power. Sometimes you can write it like 10 times 10 to the z power, right? The z plus 1 power means, all right? So here, we try to find the a and b, right? So if you plug in what we know from the given two equations, let's plug in to the x cubed plus y cubed, plug in on the top of the expression here, right? So the first term is x squared plus y squared, that is equal 10 times z plus 1's power, right? And then times x plus y is given 10 to the z power, right? All right. And then minus xy we don't know. Let's carry it over here. We don't know. And then x plus y we know, which is 10 to the z power. Now, what is xy? How is it related to the two? Now, from the equation number 1, we know that xy could be the subtraction of the two, right? So from here, what we get is xy, right, would equal the difference of this side minus this side, and then divide by 2, right? So 1/2 of x squared plus y squared, right? Yeah. Sorry. Okay. from equation 1, we know that it is x plus y squared minus x squared plus y squared, and then divided by 2. So when you plug in, that becomes x plus y is 10 to the z, and square is going to be 2z here, minus x squared plus y squared is equal 10 times 10 to the z power, right? So let's plug in here, right? So the first term becomes 10 2z, right? Plus 1. Plus 1 here can be written as times 10, right? Times 10. Okay? Minus xy. Xy is 1/2 of 10 to the 2z minus 10 to the 10z, right? And then times 10z, right? So let's do some algebra here. 10 times 10z minus half, and then minus. So let's expand it out. So 10 times 10 2z, right? Minus 12/2 of 10 2z times 10z, right? Plus half of 10 times 10z times 10z, right? We can expand it out. And then you notice that this is actually 10 to the, this part is 10 to the 2z, right? So you just cancel here, this is 2z. And then you combine the coefficient here, 10 to the 2z, and half of 10, which is 5. So that will be 15 of 10 to the 2z, right? Minus half of 10 to the 3z. So when you compare to this, you know that A equal negative 1/2, B equal 15, right? So that's going to be our final answer. So let's review the process. So we're given x plus y, right, and x squared plus y squared. We try to find s cubed plus y cubed. Again, this is related to the Newton's identity in the sense that when this is how they're related to the you know, this is s2, right? This is s3, right? And this is actually s1, right? This is s2 and s1, right? So this is how they're related, and then this algebra will help you find the answer here. All right, that's it for today. Thanks.